Hi students, in my last lecture I have discussed about trigonometric ratios for complementary angles and exercise 8.3. Now I am going to discuss about trigonometric identities. Okay, so mainly about the three laws: sine square theta plus cos square theta, which is equals to 1, secant square theta minus tan square theta, which is equals to 1, cosecant square theta minus cot square theta, which is equals to 1. About these three laws we are going to discuss now, and how we can get these three laws I'm going to discuss in this lecture. Students, if you like the content, please subscribe and share my channel. Let us proceed with our topic. Let us take a right angle triangle. Let us take a right angle triangle ABC. Oh, sorry. Let us take a right angle triangle ABC. Right angle at B. Okay. Here I will fix one angle and I'll call it as theta. So by Pythagoras theorem, what I can write? I can write here AC square is equals to AB square plus BC square. Okay. If I divide both sides with AC square here, if I divide both sides with AC square, I will get AB square by AC square plus BC square by AC square. AC square by AC square will be cancelled here. So we'll get 1 here, which is equals to AB by AC, we can write as AB by AC whole square plus BC by AC whole square. We all know the trigonometric ratios basic formula sine theta, which is opposite to theta, side opposite to theta by hypotenuse, and cos theta, which is side adjacent to theta by hypotenuse. So here AB is opposite to theta and BA is adjacent to theta. AC is hypotenuse, the longest side in the triangle, right angle triangle. So we can write here 1 is equals to sine square theta plus cos square theta. So we got one formula, one identity, sine square theta plus cos square theta, which is equals to 1. Like that we will find out the first identity. Okay, let us move to second identity now. Yes, if we divide with AC, we are getting sine square theta plus cos square theta is equals to 1. Let us divide with AB, both side. Then we'll see what will come. We'll get. If I divide with AB, so I will get here AC square divided by AB square, which is equals to AB square divided by AB square plus BC square divided by AB square. I am dividing both sides with the AB square. So I can write this one as AC by AB whole square, which is equals to, here these two values are cancelled here, and I will get 1 plus BC by AB whole square. Okay, and I can rewrite it as AC by AB whole square minus BC by AB whole square, which is equals to 1. Actually, I know that here AC by AB, we have secant theta, hypotenuse divided by side adjacent to theta, and tan theta side opposite to theta by side adjacent to theta. So based on these two, we can write here secant square theta minus tan square theta, which is equals to 1. So we got here second identity also. Okay, if we divide this entire equation with BC square, then we'll get the third identity. Let us try to find out that one also. Here AC square. If we divide the equation with the BC square, what will get? AC square by BC square, which is equals to AB square by BC square plus BC square by BC square. So we can write here AC by BC whole square, which is equals to, it is not O, it is C. So here we will get AB by BC whole square plus these two will be cancelled and we will get 1. Let us write this term also left hand side. AC by BC whole square minus AB by BC whole square, which is equals to 1. This is B. We know cosecant theta, which is equals to hypotenuse divided by side opposite to theta, and cotangent theta is equals to side adjacent to theta by side opposite to theta. AC is hypotenuse here, this one, and BC is opposite to theta. This BC side is opposite to theta. So we can write this one as cosecant square theta minus cotangent square theta, which is equals to 1, and we got our third identity also. Okay, so let us rewrite our three identities here. Again, we have mainly three identities. One is Sine square theta plus cos square theta, which is equals to 1. Secant square theta minus tan square theta, which is equals to 1. Cosecant square theta CSC cosec square theta minus cot square theta, which is equals to 1. These three we must and should memorize. Now let us move to exercise 8.4. Express the trigonometric ratio sin A, secant A and tan A in terms of cot A. Sin A, secant A and tan A in terms of cot A. Okay? Yes. See, they are asking to write sin A in terms of cot A. Okay, we can solve this one in different methods by selecting any one of the formula. Okay, yeah, I will select the third identity. I have cosecant square A minus cot square A, which is equals to 1. Why? Because here send the cot to another side and isolate this cosecant. Cosecant square A is equals to 1 plus cot square A. But cosecant is nothing but 1 by sine. So I can write here 1 by sine square A, which is equals to 1 plus cot square A. Why? Because sine A is equals to 1 by cosecant A. Based on this property, I wrote like that. So I want only sine left hand side. So I will flip the fraction. Sine square A can be written as 1 by 1 plus cot square A. Here nothing is there, means there will be 1. If we flip the fractions both sides, we will get like this. But we want only sine. Send the square to another side, it will become root. So under square root 1 plus cot square A. Okay, now we represented this sine A in terms of cot A like that. Let's write secant A in terms of cot A. Let us write secant A in terms of cot A. Okay, let me erase this one. Let me take again this one only, or else this one also we can select. Secant square A minus tan square A, which is equals to 1. Yeah, secant square A, which is equals to 1 plus tan square A. But we don't want tan here, we want cot. So secant square A 1 plus, I can write this one as 1 by cot square A. Why? Because tan A is equals to 1 by cot A. So from this we can write secant square A is equals to cot square A plus 1 divided by cot square A. Send the square to another side, then secant square A is equals to under square root 1 plus cot square A divided by cot square A. If we split the root for both numerator and denominator, we will get here, yeah, we already sent this square root on the side. So secant A is equals to square root of 1 plus cot square A divided by cot A. And now we represented secant A in terms of cot A here. Okay, now we need to write tan A in terms of cot A. Already we wrote it here. Tan A is equals to 1 by cot A. Okay, let's move to next question. Write all other trigonometric ratios of angle A in terms of secant A. In terms of secant A. Okay, let us write those. First of all, we start with sine. Let us take first identity from solution from identity 1. But I can write sine square A plus cos square A, which is equals to 1. I will separate this sine square A and I'll send this cos square A to other side. 1 minus cos square A. But I can write this cos as 1 by secant. Why? Because I wanted to represent all ratios in term of secant. So we can write this sine square A as 1 minus 1 by secant square A. So from this we'll get sine square A is equals to secant square A minus 1 divided by secant square A. So sine A, send the square also to other side, we will get under square root secant square A minus 1 divided by secant square A. So here we'll get sine A is equals to under square root secant square A minus 1 divided by square and root will get cancelled, we'll get secant A. So we represented sine in terms of secant. And the second thing is very easy. Cos A we can write directly 1 by secant A. Okay, then coming to tan, this is second one. Let's move to third one. We have secant square A minus tan square A, which is equals to 1. And from this tan square A is equals to secant square A minus 1. We want only tan A. Tan A is equals to under square root secant square A minus 1. So we represented here tan A in terms of secant. Then coming to secant, however, it is secant only. Secant A is equals to secant A. Then cosecant we wanted to write. Okay, so what we can take here actually, yes, we have identity cosecant square A minus cot square A, which is equals to 1. If we take this, we will not get, I think. Yes. Let us take the first identity. We will get let us take first identity, sine square A plus cos square A, which is equals to 1. Sine square A is equals to 1 minus cos square A. Send this cos it on the side, and sine square A is equals to 1 minus 1 by secant square A. Why? Because cos A is equals to 1 by secant A. So from that we can write like this. Sine A, sine, the sine also we can write here. One thing, cos A is equals to 1 by secant A. This sine also we can write as 1 by cosecant A, cosecant square A, which is equals to secant square A minus 1 divided by secant square A. If we flip the fraction both sides, we will get cosecant square A equals to secant square A by secant square A minus 1. We are flipping the fractions both sides. Yeah, then send the square root on the side, then we will get cosecant A is equals to secant A by under square root secant square A minus 1. And the last thing, cot we wanted to represent in terms of secant. Sixth thing, cot in terms of secant. Yeah, we have secant square A minus tan square A, which is equals to 1. So from this, if I separate tan square A is equals to secant square A minus 1. This tan I can write as 1 by cot square A, which is equals to secant square A minus 1. So from this, if we flip the fraction, cot square A is equals to 1 by secant square A minus 1. Then here we can write cot A is equals to 1 divided by under square root secant square A minus 1. Okay, so we almost converted every ratio, trigonometric ratio, into secant in terms of secant. Here sin A is equals to, and this is tan, this is secant, this is cosecant, this is cos, this is cot. Okay, all those we converted here. Yeah, let us move to next question. Question number 3. Evaluate sine square 63 plus sine square 27. Okay, question number 1. Sine square 63 plus sine square 27 divided by cos square 17 plus cos square 73. Here we should read the question and we should understand the logic. Here they mentioned two angles. These two angles are complementary, at the same time sine square. So we should convert one of the ratio into cos. Here we should convert one of the ratio into sine. Then we'll get sine square theta plus cos square theta. So we can do here like this. Sine square 63 plus this thing I will change a little bit. Sine square 90 minus 63 I can write, divided by cos square 17 plus cos square, I'm changing here, 90 minus 17. So here we'll get sine square 63 plus, we have a formula in complementary angles, sine 90 minus a is cos a, and another thing, cos 90 minus a is equals to sine a. From these two, sine 90 minus 63 we can write as cos 63. Here we have square, so that we'll get square here. Cos square 17 plus cos 90 minus a is sine a. Based on that formula we can write sine square 17, and by using identity sine square theta plus cos square theta, which is equals to 1. Based on this identity we can get here 1 divided by 1. Let's move to second question in this. Let us copy the question. The question is sine 25 into cos 65 plus cos 25 into sine 65. Yes, let us zoom it. Sine 25 into cos 65. Yes, this we can write as sine 25 into cos 65 is nothing but cos 90 minus 25 plus this cos 25 you write as it is. The sine 65 can be written as sine 90 minus 25, so that we'll get here sine 25 into cos 90 minus a is sine a, so sine 25 plus cos 25 into sine 90 minus a is cos a, which is cos 25. So we'll get here sine square 25 plus cos square 25, which is equals to 1, based on sine square theta plus cos square theta, which is equals to 1. Let's move to next question. Choose the correct option, justify your answer. 9 secant square a minus 9 tan square a is equals to 9. Why that is correct option? We'll see now. We have secant square theta minus tan square theta, which is equals to 1. And from the question, if we take out 9 common from both terms, we'll be left with secant square a minus tan square a. So that 9 into, this is our formula, so 1, which is equals to 9. And that's it for today. We'll meet in the next video. Thank you.